Hey everyone, hi, this is Yogesh. In this video, I'm going to talk about statistical data analysis for machine learning. So, what is data analysis? This is a process to inspect, clean, transform, and model your data. This process is to extract insights and patterns from your data. And then this is all we are doing to improve machine learning model performance. Moving next is type of data analysis. Descriptive analysis, inferential analysis, quantitative analysis, and qualitative analysis. There are other analysis types as well. Okay, we'll take a look at that maybe in future. But for this video, we are going to talk about descriptive analysis. So descriptive analysis is a simple process that help you understand and summarize the data. So it shows the basic features of your data sets like finding the average, finding the range of your data, that is highest and lowest numbers or values in your data, and then how your data is spread. Okay, and this should be the first step in making sense of your information. Okay, so this is what generally people say that this should be the first step. Then what is descriptive statistics? Okay, we saw that, right? And then there are three types of descriptive statistics: measure of central tendency, measure of variability, and measure of frequency distribution. So these are the three types of descriptive statistics. Now let's look at measure of central tendency for this video. So measure of central tendency is the statistical value that describes the central position within the dataset. So there are three types of values, okay, in the central tendency, that is mean value, mode value, and median value. So let's look at these values one by one, and we'll also see some Python programming how to find these values in a given data set. Yeah, so let's first look at mean. So mean is the sum of observations divided by the total number of observations. This is the standard definition that you will come across. And it is also defined as average, which is the sum divided by the count, which is a very common definition that we have come across so far in your life, right? So here x is equal to observations. Yeah, here x is equal to observation and n is the number of terms. Okay, so let's look exactly how what this means. Yeah, so see that you have a range, a value, a data set, okay, with range like say, let's say that you have 10, 20, 30, 40, and 50. This is your data set. So we are asked to find the mean. Okay, so what you are going to do is you are going to sum all these numbers, okay, and then divide by the count of these numbers. So that is 10 plus 20 plus 30, 40, and plus 50 divided by how many values are these? 1, 2, 3, 4, 5 divided by 5. So this total comes about like 150, okay, and then divided by 5, that is 30. So here 30 is your mean value, right? Now, how would this look like on a graph? So this is your graph. Okay, let's say that this this range here is density. Okay, and then let's say that your plot looks like this. Okay, so you have 10, 20, 30, 40, and 50. Okay, something like this. Okay, let me clear this out a little. 20, 30, 40, and 50. So your data, okay, your data is spread very nicely in this range. So your starting range is 10, your ending range is 50, and your data is very nicely spread. So you have a good density, okay, in this area. So you see that this area is highly dense, okay. So we'll look at this what density is and what this exactly means. But for this instance, say that this is your plot and you have a range from 10 to 50. Now, how would you calculate the mean of this value is I explained here, like you sum the numbers here and then you divide it by the number of values, the count, and that comes about 30. So on this graph, this is going to be your mean value. Okay, so this is very simple to understand. I hope you got it. So it is also possible that your data, okay, that you have is spread like this, something like this. Okay, and your range is starting from 10, 20, 30, 40, and 50. Okay, so this is what your data looks like. So in this case, in this case, would your mean be still 30? Would your mean be still 30? Right. Yes, it is going to be still 30 because the formula says that it is the sum of the values divided by the count. Exactly, right? So your mean is going to be the same whether your distribution is like this, or for that matter, your distribution is like this. So you have like 10, 20, 30, 40, 50. Okay, so your mean is always going to be here at 30 for this data set. All right, so let's look at how do we do this in Python. All right, so here I'm using Anaconda and I have installed Jupyter Notebook using Anaconda. So I'm going to use this for this practical. All right, okay, let me close this as well. So here I have already imported Pandas and NumPy. So I'm going to do this df is equal to pd dot read underscore csv. Okay, and then I'm going to pass cars, sorry, cars dot csv, and then delimiter is equal to comma. Okay, and then I'm going to print df dot head, which is going to give me top 5 rows from this data frame. Okay, so you can see uh, you have this CSV file cars.csv. There are columns ID, name, location, year, kilometers driven, fuel type, transmission, owner type, mileage, engine, power, seats, updated price, and price. Okay, so this is what your CSV files looks like. Okay, and then we are also going to do df dot shape. Okay, so it is going to give us exactly what are the uh, exact what df dot shape, yeah, sorry. So you have 6,020 rows and you have 14 columns in the CSV file. Okay, that you can see. Now let's look at one column here. So you want to analyze a column. Let's say that you have seats column. Okay, you want to analyze seats column. So you want to understand what is the mean value of the seats column in your data set. So what you're going to do here is df of what is the name seats. So you have to make sure that you type in the exact name of the column with all the case sensitive data. Even if there are spaces, you have to mention that. And what you do is ch dot mean. So this function is going to give you the mean value for your column seats. Okay, so it is 5.27 is the mean value. Now, how do you visualize this? Okay, let's visualize in this program as well. Okay, so let's continue this practical and see check how do we visualize this seats column on the graph. Okay, so for that I'm going to import matplotlib plot lib dot pyplot. Okay, as plt, is that correct? Matplotlib dot pyplot as plt, and import Seaborn as sns. Okay, so let me run this and see if there is an issue. It is still importing. Okay, so import is done. Now what you do is you have to use your PLT and SNS, that is Matplotlib, PyPlot, and Seaborn to draw the graph. Okay, so first thing that you do here is that SNS dot, we are going to use distribution chart for this dist plot. Okay, and then you're going to pass in your uh, df of seats. Okay, and then you're going to do plt dot show. That is going to, this should work. Okay, so you see, okay, so ignore this warning as of now. So what you have done is, using Seaborn library, you are plotting this distribution plot, and in this distribution plot you are passing the seats column, and then you are doing plt dot show, which is going to display this graph here. So here you see you have density on this side, and you have seats on this side. So you see your data has some density at 4, that is some of the cars are 4-seater. You have a large density at 5. Okay, this is 5, which says that you have large number of cars having seat capacity 5. Then you have very less car with seat capacity 6. You have moderately less cars with seat capacity 7, and then you have a few more cars with seat capacity 8. Okay, now what we just did above is, using Python we found out the mean value of your seeds column, which was about 5.27. Okay, so your mean value is somewhere here, 5.27. Okay, so it is that simple to find out the mean values using Python, Pandas, and plotting that column using PyPlot and Seaborn library. Let's go back to our presentation. Okay, so let's look at what is median value. So the median is the middle value in the sorted data set. So what does it mean? We'll look at it. It also says that if the number of values in your data set is odd, it is the center value. That is, median value is the center value. If even, that is, your number of values in your data sets are even, then it's the average of the two middle values. Okay, so let's look at this on actual graph. What does that mean? All right, so here you have your data set, which has data like 1, 2, 3, 4, 5. Okay, so you are asked to find a median. Okay, but in general, this data is not going to be present like this. So your data is going to be like 5, 3, 1, and then 4, and then 2. You'll get the data like this. So to find the median, what you have to do is, you have to first sort this data. Okay, so once you sort this, you will get 1, 2, 3, 4, and 5. Now what you have to do is, you have to find the central or the mid value of this data. So in this data, 3 is the middle value. So 3 is going to be your median value for this data set. Okay, now let's take another example. So you have, let's say, 5, 3, then 2, 2, and you have 4, and you have 1. So how you are going to do this? Again, you have to sort it first. 1, 2, 2, 3, 4, and 5. Okay, so this is your sorted data set. Now what it says is the middle value. So this is the middle value, right? But how do you find this value? Then what you do is, take the average of these two numbers. So 2 plus 3 divided by 2 is equal to 2.5. So 2.5 is going to be your median value for this data set. Let's take another example. So let's say that you have 5, 3, 2, 2, 4, 4, and 1. Okay, so here the sorted data set is 1, 2, 2, 3, 4, 4, and 5. So what the definition says, that it is the center or the middle value of the sorted data sets. Your middle value here is 3, because on this side you have 3 elements, on this side you have 3 elements, and this is the sorted data set. So middle value is 3. So this is your median. for this data set. All right, so I hope this is clear. Now let's look at what exactly the relation is between mean and median. I'm not going to save this. So in a well distributed data set, so let's say that you have a very well distributed data set. So this is your data set, okay, and then you have values like 10, 20, 30, 40, and 50. Okay, so what we saw is 30 will be your mean value for this data set, because what is the mean value definition? Like 10 plus 20, it is the sum, and then we take the average. 30, 40 plus 50 divided by the number of elements, that is 5. So that is going to be 30. So here 30 is going to be your mean value. In the same data set, if you are asked to find the median value, okay, then it is going to be like the middle value, that is again 30. So 30 is also going to be your median value for this data set. Okay, so this usually happens when your data is well distributed, okay, or it is a centrally distributed data. I hope this is clear. So let's take another example here. So let's say that you have data like this and you have data distributed like this. Okay, so you are starting with 10 and then this is your range 50. So you have again like 10, 11 and 12, something like that, and then 13, etc. So this data is very concentrated here, and then you have data like this. So when you are asked to calculate the mean, what you are going to do is here is like, let's say that this is 10, 11, 12, 13, 14, 15, etc. Then your mean, you will take the average of these numbers. So your mean will be somewhere here. Okay, your mean will be your mean will be somewhere here. Okay, so this is going to be your mean value. But if you are asked to calculate the mean median value of this, then what you look at is, this is my sorted data set. Let's assume that this is a sorted data set, and then I'm going to find the middle value here. So this is going to be your middle value. So this is going to be your median value for this data set. So you see that this data is actually not well distributed. This is distributed largely on the left side, okay, and then it is less distributed on the right side. So for this, the median value will be on the right side of the mean value. Generally this happens. Let's take another example. So you have another data set where you have data like this, okay, and then your range is like again 10 to 50, and then you have like 20, 30, and then you have 41, 42, and then majority of the values are concentrated here. Okay, so your mean is going to be somewhere here. Okay, if we calculate this, then this mean is going to be here, and then your median is going to be the center point here. Okay, so this is going to be your median value, right? So you see here, your data is very highly concentrated on the right side. Okay, then your mean is here, and then your median is going to be on the left of the mean. I hope this is very clear. Okay, so let's look at what exactly is the plot distribution will look like on the graph here. Okay, so let's go back to Python again. So I have imported Matplotlib, PyPlot, Seaborn, Pandas, and I have two data sets here, data 1 and data 2. Okay, so how, let's look at this data set. How data 1 is distributed, it has highly concentration of data on the left side, like 10, like number of occurrences of 10, 15. Okay, they're concentrated, and then you have single occurrence of 30, 40, 50. In data 2, you have single occurrence of 10, 20, 30, but multiple occurrences of 35, 40, and 50 here. So your data 1 is concentrated on the left side, while data 2 is concentrated on the right side. So let's look at the mean, median, and how these data sets look like on the graph. Okay, so let's do one thing. df equal to pd dot data frame. Oops. Data frame, we are going to pass data 1 here. Okay, and then df will going to print df dot mean, okay, and then df dot median, okay, and then sns dot dist plot, we are going to pass df to this method, and then plt dot show, okay. So I'm going to run this plot. Data 1 is not defined. Why? Data 1, okay, let me run all cells. Yeah, right. Okay, because this error came because I did not execute this uh, cell. Okay, so here you can see the mean value here is 19.33 and you have a median of 15. Okay, for this data set, data 1. Okay, so mean is 19 and median is 15. So mean on this graph, okay, so this is now data 1 graph. You see this is high concentration of data in between 10 and 20, 30, and then you have minimum concentration of data on the edges like for 30, 40, 50, etc. And then your median is 15 here. Okay, so this is your median and your mean is 19.33. So this is your mean and then this is your median. Okay, now let's plot this same diagram and for data 2. Okay, I'm just going to copy paste that same data again. Okay, and then data 2, and I'm going to execute that. So you see here the data is highly concentrated on the right side, that is highly concentrated between 30s and 50s, and then there is a less concentration from 10 to 30. Okay, your mean is 38, your mean is 38 somewhere here, and your median is 40. Okay, so this is how the actual distribution of the data looks like on the graph. So we have always seen very simple examples of the graphs, like okay, how your graph will look like, and you have always got like very linearly distributed graphs, and then there is always mean and median of these data sets are always overlapping or they are the same values exactly. Okay, but in this example you see that data is actually distributed in this region, and in this graph this data is actually distributed here. Okay, and then that is why the median and the mean values are not equal, they are different. Okay, I hope this makes total sense. Thank you.